Alright, welcome back. New game, new rules. Alright, we're going to make the def normal. Let's see. Make sure I got some bars going. Okay. We're going to make the def normal utilizing about 20 bucks worth of electronics. And I looked up making a def normal through tracking. I didn't find anything. I did find how can def barriers be overcome. Alright. I went to this guy's site, and I can't pronounce it. I had seizures. I can't hit all the letters, so bear with me. Wonderful gentleman, evidently an engineer, high-class engineer with access to some really nice toys. And I found this project, and don't trip out. I'm going to go into some heavy electronics. If you're not familiar with electronics, I'm going to show you a whole soiree of them, and then I'm going to tune in on one circuit. Very simple, very easy to make. And we're going to start out. This is it's called a VU meter, and it's the same thing on your phone when you're playing music and you see the bars going up and down. Okay, and then I liked his version, so I made one. But his plugs into a USB in the bottom. And the reason for that is because he needed 5 volts for his microphone, not for the chip. So I did a 9-volt battery and did the same thing, but I cheated and made it a simpler circuit. And there it is if you can see it. And don't worry, I'm going to show some close-ups and do a different perspective here. So I'll pull that out and make it available. And I'll show you the web pages. And look, I know people are on a cell phone. I'll do the links so you can go to them and see them bigger. And I'll figure out how to fix that by scooping these pictures in the future. But this is the LM3915 circuit that was used in that build. And then he added a microphone and then a USB adapter. This is an IRF 840. It's a really, really simple little MOSFET here. 3 wires coming out of it, and I'm going to show you that circuit. It's just a microphone and a 9-volt battery. Probably put that in a pair of glasses. There's the circuit, so you can see this is the touch on off. Another circuit. This is the one that I chose, the KA2284. There's also an 8.5 version. It's an integrated circuit by Texas Instruments, and I'm going to show you how we build this, which is what I've already built. And we're going to go into some more options here. This is how you obtain it. You can go to Amazon, and this is a do-it-yourself kit. It's cheaper on eBay. And this is a build-it-yourself kit, which is what I ordered because I'm on a budget with all of my parts. And you can buy a pre-built kit, so don't trip out and make the def normal. This is what was missing, in my opinion, on the other invention there, even though I like it. Much more credible and better built than mine. This is a 12-volt microphone. If you clip just this part off, you'll end up with this little component, if you can see it, just a little circuit board and a microphone, and then you can actually complete the circuit without having to use any adapters and make it portable, which is the idea. Now, I ordered these, and these are the 5-volt ones, so they're coming, and then I'm going to order this little guy and adapt the power from 9 volts down to 5 volts, show you how to do that. And the other ingredient that you're going to need, don't trip out, it's a simple electronic circuit you can order at a couple bucks, is a cell phone. And you don't have to worry about having a connection or not a connection, because if you're deaf and you're trying to speak to somebody and your connection's going on and off, you're going to look really stupid and not accomplish your goals. So I recommend you download something like Google Translate, and what you're looking for is voice to text. If I'm deaf and you're talking to me, I need to see the words. Really simple. That's the piece that's missing, and I can obviously write on a piece of paper or type on a screen so you can see it and not infect myself with your cooties. So this is going to be a necessity, and I always try to do it the right way. Here's a pen and paper to communicate, real simple. But there's also a program for the deaf that I thought that I put in here somewhere, and I forgot it. Anyway, I found pen and paper. There's a program for the deaf to communicate. Now, what we're going to do with these LED lights is the same thing as surround sound. We're going to use this just like how a human tracks, left, right, far away, close. Okay, we're going to make basically a really simple sonar system. Nothing expensive. And instead of using 2 surround sound speakers, we're going to use 1. And we're going to use 3 up front, the center, the left, and the right. Okay. And this is how real people who play with science figure out how to utilize electronic circuits. You download their PDF that shows you all the basics of it and explains it to you. So, let's see, this is the LM395 that was used by that engineer gentleman. It's obviously outstanding, but that's not the chip that I chose. I'm just going to show you 3 ways from Sunshine on how to do this, and you pick out which one's easier for you. This is that IRF 840 chip, and this will be your easiest solution. And I'm going to pause this and switch perspectives so I can do a little bit of show and tell here. Okay, show and tell time. Alright, this is the little circuit that I duplicated, and I used that KA chip because it's half the connections, and I'm disabled, so it made it a little bit easier. And you can see here, I'll talk, and then it lights up. Hello. Oops. Hello. 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 Can't sing for shit. Okay, so you can see that it's a 9-volt battery in the bottom, a little casing. It's the same circuit that he did, except a lot uglier with a lot uglier solder joints. And there's the little microphone on top. That's 12 volts. So it'll take the 9-volt battery, and then you can make it portable just like that other gentleman did, and not have to plug it into USB. Now, he did a sculpture in his defense, so, and his is much more beautiful. Here, I'll show you my ugly solder joints. I'll give you a solder lesson down the line, but let's make the def normal here, okay, through tracking. Now, you've seen this circuit all day long, you just don't realize where you've seen it, and it's your battery indicator. It's the same circuit on your cellular telephone. That little battery circuit's the same little jobber. So, this, when you take away the microphone circuit so that we can see it in its simplicity, see here. There we go. And scoop that battery. And there we go. Now, what I did was, this is merely a cell phone with a video game on it and controllers, and that's the audio out, which they usually don't do on cell phones anymore. Now it's all Bluetooth. So if you got a stereo, anything that puts out music, you connect it to the input, and then you have it connected to the electronic circuit, and then it responds to what's going on, the stimulus or the input from the game itself. As you can see, it reacts. Okay, so that's this circuit broken down, and I'll turn it off so you can see it up close a little bit. If you're on a cell phone, I'm sorry, we're dealing with fine detail electronics here. I would urge you to get a bigger screen. I'm doing my best here so you can see it, but it's just a simple chip, just a couple of connections here. I'm going to try to flip it over so you can see the back side. Attempt to hold it steady. Not much to it, just electronics soldered to themselves, or electronic components. So, let's get into making a def normal on how we're going to achieve this. What we're going to do is we're going to figure out where we want to put it. And I was thinking a hat, pair of glasses. I can put it anywhere I want, folks. That's the neat thing. Alright, so I wired up a little hat structure. Sorry, I can't zoom out on my camera anymore, but what I did was I took a circle, measured my head, that's the bottom, and I pictured one of those goofy hats with a propeller on top, and I even put the mount for it, believe it or not, and then I made a brim, And the reason for this is so I can explain to you how I'm going to make the def normal. So you can see how I have LEDs on each side. That's going to be left and right. And if you imagine, I had a centerpiece here, but I'm still working on it. That's why this is part 1. There'll probably be a part 2 and 3 on this, so don't trip flip. Let's picture a middle one right here where my finger is, okay? The idea here is very simple. If it lights up over here on this left side, where my hand is, and I can't see it too well, the idea is to turn your head till it goes to the center, and those light up more. That's how we're going to achieve tracking, and we're going to do a 3+1 system: left, center, and right channel. And then we're going to put one in the back as our backup unit, so in case somebody says, "Hey Mike," and I'm in a hallway, I can turn around and respond to it. So all that was necessary was the tracking, and you can clearly see that this electronic circuit is very small and compact and portable. And with 4 of these circuits in conjunction, you can achieve tracking of a deaf person so that we can find someone communicating with us, something falling off the shelf, a car crash, some bad person coming up behind us, and we're able to track within 3 heartbeats of a normal human being. That's the goal here. Now, in the future, I'm going to take this and I'll show you how we incorporate all the circuits and the electronics together. But I'm going to show you a little more before I stop this and get my air conditioning back on. Sorry about that. Okay, get rid of my hat. Got stuff in plastic baggies. Here's your dope. All right. This is... change my light spectrum. And you can see this is the electronic circuit for an LM395. And the completed circuit is going to look a little bit like this. And you'll clearly see why I chose the other circuit. This is the LM395 circuit without the audio amp circuit, which is basically just a little 386 chip. So you can see this is a little bit bulky. Let me show you the one that I chose, and then you can see why I went in this direction. Now, you live in your parents' basement, you got a bunch of money, go with the big one, man. I can't afford it, dude. All right? Look. This is a friendly site. If you're young, you want to learn how to play around with some electronics and some other stuff, this is a safe place to be. Watch this. You see the difference in the size between these 2 components? I hope I'm holding it. Now watch this. Here's 3 of them in comparison to 1 on the electronic board. Let's see. Find out where my camera is pointing here. I'm at a weird angle. And zoop, having to do it backwards. So you can see, because these 3 are compact, I'm going to go with that instead of this big bulky unit. And you're going to have to wait a second. To solve this, all one would have to do is put 3 of these onto the brim of a hat. Okay? Yeah, it's going to look a little bit stupid, and down the road, don't worry, there's much smaller electronics. I'll show you how to make it pretty stealthy. But that's the basic concept. And then obviously we want one on the backwards, pointing backwards. We can just put our mic back there, make it a little auxiliary. Okay? Now, you're going, I'm going to look goofier than shit. walking around with electronics duct taped to my head and a 9-volt battery and 100-degree heat. So here's our frame, and I have some sample electronics. I had more, but if I make everything flush, the hat will pop over this. Well, it's not popping over that one. I got my propeller mount on the top. But as you can clearly see, I used a little bit of integrity too. That Colorado integrity. And when you push this in, it doesn't fit. So I'll have to re-engineer it. The other one fits flush. But the idea being, you can make a wire frame, hide it, and just have it underneath the front of the brim. So that's where the goal is going with this. True goal is somebody's going to copy me, make a fortune off of it, and it's a stupid, simple invention that was already done in the 1980s, folks. This chip is from the 80s. It's from my era, if you can believe that. Now look, I'm going to give you a quick electronic soldering lesson. We'll use a little bit of humor. You are going to burn yourself, so get your swear jar out. And here's some of the stuff I threw at the wall, just so you know, and I got a little bit frustrated and stuff didn't work out. So, when you electronically solder, you are going to burn your hands. So, if you're a little wimp, go get some cream and bandages and hold them nearby, because it doesn't feel good. But it's a very simple deal here. There's only a handful of components here. Put the light on it. Very simple. There's a capacitor. The long metal wire is going to be your positive, and it's clearly marked with a negative side on the capacitor itself. Okay. And I actually have samples, but we're not going to go there. There's also a resistor on this. That's the capacitor, the guy that's sticking up here. I'll bend him out for you. That little guy there with the chrome top. There's your little IC chip, and there's 2 resistors. Resistors don't have any electronic. You can put them in either way. All it does is resist electricity when you solder. The chip has a notch on one side. Look it up. There's pins 1 through 8 or 1 through 9 on chips this size. Okay, and when you find the pin markings, you'll know where to make your connections. Or if you want to go the easy route, buy it already pre-soldered. But it's funner to do it yourself, plus it's cheaper. Now, the only other component is a little variable potentiometer there, that little thing with the white screw on top, and it's pointed like a triangle if you look at the bottom of it. So there's 1 in the center, 2 on the sides. Very easy to match up. And the LEDs have a polarity as well. Same thing again. Long lead is the positive, short one's the negative. The only way to test it if you've clipped it and used parts is to hook it up to a resistor and a 9-volt battery and figure out which one's the positive and the negative. So real simple. Look, I'm disabled. I got a heavy neurological condition. Out of 4 of these boards, 4 of these, I can get one to fly, okay? So if I can do it, you can do it. I don't want to hear it. And you can purchase them. Most of you got more money than me, so you can purchase these pre-made. Now, somebody wants to one-up me and go with the big circuit, I'm leaving that open to you. So young guys out there that want to one-up me, come on, bring it on. You want to one-up me big time? Build one of these for a deaf person. Build one of these electronic circuits, even the cheap one. Okay, so when I come back next time with part 2, I'll have a hat built for you. I'll be playing with some glasses, and I'll be playing with all kinds of other stuff here to make the deaf normal. But let's go back to that tracking, just so we understand where we're at on that. Oops. Testing. And by the way, if you're not deaf, you're going to build the ultimate party hat, the ultimate party glasses, and you can put these electronics anywhere you want. It's kind of cool, folks. So even if you're not deaf, you can have a full UV spectrum on your hat. So maybe I'll build one of those down the road. Don't hold your breath. So, tracking. How do we accomplish this? We did the 3+1, but we can do it another way. If we go portable with a small unit like this little one that I built with a 9-volt battery, and I go to talk to somebody and I put it down on the counter, I can move it to track them as well. The original way God gave you was by turning your head left to right to sweep. Sonar was stolen from the whales, obviously. Whales aren't really kind about that, nor happy. There's the electronic circuit. That's how it works. This is a KA2884 chip, just so you know when you look it up to purchase. And look, you guys on cell phones, I'll try to fix it where the pictures are bigger for you and you can see it a little bit better, but this one was a little fine detail, so bear with me. I'll put some links up for you guys. Between these two programs, in other words, utilizing speech to text and utilizing tracking, the deaf can become normal again, folks. Forgot what the next episode was at breakfast. So there you go. You guys have learned something about electronics today and how to make the deaf normal. Very simple. I'll do a part 2 where we'll do some more show and tell, and I'll get it built up and working so everyone can see it going. I had to order some parts, so it'll be a couple weeks here, folks, hopefully sooner, but I'm also a little slow at putting this stuff together. But that completes part 1 of Let's Make the Deaf Normal, and going on to the next video. Thanks for watching, and appreciate the views. No commercials here, folks.